Following on from the PowerPoint, or sort of basic theory of gas laws, here's some examples. Using the general gas law. So here's one question. There's a sheet going through what these are, but these are the workings out. So use that sheet along with these answers. So we've got a gas of pressure 3 megapascals and a volume of 0.7 cubic meters. We're going to increase the pressure to 8 to see what happens with the volume. We're going to keep the temperature constant. So using the gas law, P1V1 over T1 equals P2V2 over T2. Because we're keeping the temperature constant, we get rid of that one and get rid of that one. Or you could put numbers in there. You could just say T1's 100 and T2's 100. Doesn't really matter. But because the temperature is constant, we'll get rid of the T1s and T2s, which leaves us with that formula there. P1V1 equals P2V2. P being pressure, V being volume. So this is before and this is after. We need to find V2. So I'll just rearrange this formula to find V2. So P1V1, if I bring the P2 down, because it's multiplied by there, divide both sides by P2 gives me that. So then it's just a case of putting your numbers in. So P1V1 over P2 equals V2. They're all in the same units, pascals and cubic meters. There's no temperature, so we haven't got to worry about converting to Kelvin. So P1V1 over T1. There's P1, 3 mega. Don't forget the mega. There's volume at the start, 0.7, and this one is the pressure after compression or expansion. It all depends on what's going to happen. So that's going to be 8. So put this in your calculator. You can do it this way if you want to. So open a couple of brackets. 3 times 10 to the 6 times by 0.7. Close that and close that. All divided by 8 times 10 to the 6 equals 0.2625 cubic meters. So by increasing the gas pressure, we've shrunk it, which makes a bit of sense because we're squashing it, so the pressure will go up. So that what happens when we increase the pressure to the volume, obviously keeping temperature constant. Tick. Number 2, volume of 0.2 cubic meters and a temperature of 25. Don't forget, we need to convert that in a bit to Kelvin. So that's before, and then we're going to increase the temperature. So what we're doing now is we're increasing the temperature to see what happens to the volume. The pressure is constant. So we can use this formula, P1V1 over T1, P2V2 over T2. Because the pressures are constant, we can ignore them, which just gives us V1 over T1, V2 over T2, which is that one there. So we know V1 and we know T1. We're trying to find V2. We don't know what V2 is, and we know what T2 is. Don't forget, we've got to be in Kelvin, so these degrees C's have got to be converted into Kelvin. And to do that, we add 273. So 25 plus 273, shouldn't need a calculator really, 298 Kelvin. And then 100 plus 273 gives me 373. So they're the numbers we're going to be using, because we've got to have it in the right units. So now we know this formula, we need to rearrange for V2. All I'm going to do is bring the T2 up to there, which gives me V1 T2 over T1 equals V2. So this will tell us what happens to the volume when we increase the temperature. So V1 is 0.2, T2 is 373, and T1 is 298. So stick that in your calculator, and we can do 0.2 times by 373, press equals, divide that by 298, sorry, 8, is it 8? Yeah, equals 0.25, so it's expanding a bit. Tick. So we keep the pressure constant, we increase the temperature from 25 to 100 degrees C, obviously in Kelvin, and that's going to cause the gas to expand, the volume to expand. That's number 2. And number 3, we've got a gas with this volume, a pressure of 200 kilopascals and a temperature of 25 degrees C. We'll have to convert that soon. And we've also got T285. We'll have to convert that. Pressure 650. So we're decreasing the temperature and increasing the pressure. What's going to happen to the volume? Because we're changing a few things now, we've got to use all of this formula. There's nothing being kept constant. So we're going from 200 kilopascals to 650. So we're increasing the pressure. So that's going up. And we're also increasing the temperature from 25 to 85. That's also going up. So if we increase both of them, what happens to the volume? First thing we've got to convert is convert these into Kelvin. So 25 plus 273 will give you that. And 85 plus 273 will give you that. So they're the numbers we're using. That's the formula. Obviously we need V2. So what I've done here first, I brought the T2 up. So I brought this T2 up to there. P1 V1 T2 over T1 equals P2 V2. And I leave the V2 there and bring the P down to there, which gives me P1 V1 T2 all divided by T1 over P2. Gives me V2. So work that out, I'll give you the volume. What I've done here is just to make sure everything goes correctly, I've worked out the top bit and then I've worked out the bottom bit. Obviously if you keep it all in one go, it's a lot easier, so we'll do this, open a bracket. So 200 is P1, just to make sure, yeah. V1 is 0.1 and T2 is 358 Kelvin. T1 is 85 in Kelvin, yes. 358. Hang on. What have I done? 85, 358, yeah. And T1 is 298. Panic then. So T1, P2 is that. So all in one go. 200 power 3, close that bracket, times by 0.1. I'll overkill on the brackets just to make sure. 358. Close that. Divide that by overkill on the brackets. 298 times by 653. Dink dink. Hopefully 0.037, 0.0369, 0.37 cubic meters. So it's gone from 0.1, right? So it's been compressed, the volume has shrunk 0.037. So that's using all of that. That was using all of that form. Nothing kept constant because we changed pressure and we changed temperature and that changed the volume. So we can check if you want to. Always good to check. You know P1 V1 over T1 is P2 V2 over T2. So these have got to equal. So what I've done there is I've worked out what P1 V1 over T1 is. So P1 is 200, V1 is 0.1, and T1 is 298. So I've worked that out. It gives me this. And then I've worked P2 and V2 out just to check. So P2 is there. V2 is what we worked out here. 0.3. I've used 0.0369, just a bit more accurate perhaps. And T2 is 358. So it gives me roughly the same. Obviously, there's things where we've rounded things up, especially when we did the volume. So that's where the little slight error is, but that's just rounding. So P1V1 over T1 is P2V2 over T2. So they've got to be the same. So that's just a couple of examples, or 3 examples on using that gas law. The only thing you may trip up on is if you don't convert the temperature into Kelvin and you forget to put mega in, or you forget to make sure everything's in the right units. So hopefully that helps. Over and out.